Welcome to the talk. My name is Claus Ibsen. I'm from Red Hat. I've been full-time Apache Camel developer for many, many years. Feel like a lifetime, at least in the IT industry. Also wrote a couple of books on Camel. The second edition of the book is not yet complete, but in 3 or 4 or 5 months it will be finished. And thank you for having me here. This is my 3rd time in a row at this Java conference, so thank you. So what is the goal of this talk? So this talk is for developers, is for Java developers or Camel developers, and how we as a Java developers can get started building cloud-native application that can run on a cloud container. And to do that, we need to build and run our applications as containers. And then we need to take these containers and run in a container platform, such as Kubernetes and OpenShift. So as a developer, when you get started developing application for the cloud or for the container world, there's a lot of things to start to learn. For example, container platform is much more dynamic, so how do you make your applications be able to discover each other? How do you make your application to communicate internally in the cluster, but also externally? What about security, storage, configuration management, scaling, and so on and so on? So suddenly there's a lot more to learn and master as a Java developer. Now in this talk, we're only going to touch the top of the iceberg, the tip of the iceberg, how to build and run some Java application on a cluster. And running on a cluster, how do we get a cluster? Now, I like to say that I like to think that there's a cursor blinking somewhere. So me, as a Java developer, I have some power. So what I would like to do is to be able to run and develop locally on my laptop using a little mini cluster here. So I'm in power. So if something goes wrong, I can just do the usual trick, reboot my machine, or maybe kill the cluster, install it again, and so on. And also, whatever I do to fuck it up, I don't show it to the world or the other developers, so I don't get embarrassed, right? So instead, if we have a shared cluster, you might do some stuff that trip over other people's work, and so on and so on. So having it locally is a good way to get started. But how do we actually install and run a local cluster? Well, that's become much more easier in recent time. You can install something called a minikube if you run Kubernetes, or minishift for OpenShift. These are the 2 popular choices today. When you run minikube or minishift, you only need to install some virtualization software up front. If you're running on a Mac, it's called Xhive. If you're running on Windows, it's called Hyper-V. And on Linux, they also have virtualization software as well. When you got that installed, then you can install either minikube or minishift. To use OpenShift, you just go to the minishift website on GitHub, and you can download it and start it using the start command. And this is what I had done on this laptop here. So I have a local mini cluster running here. So when you have the cluster running, one of the first things you might want to do is to make sure that it seems to be working. And by having minishift or minikube, they come with a little web console, so we can actually access this and see what's going on. So on the command line, you just type minishift console, and it opens up in the browser, and you can see it. So just very briefly, just show you the console. So here is the OpenShift console, and it creates a default product called My Product. You have that one to play with. And you can go in here and see something going on with the applications being deployed, and your builds and your logs, and so on and so on. I already have something running here because we're going to build a demo, and I already created part of that demo up front. So in interest of time, that's where you can see some blue there with a circle and says 1 part running. Okay. Now let's go back to the slides. Also, when you work with a mini cluster on your computer, there's some command line tool that is very good to be able to use. There's an OpenShift command line CLI called OC, And for Kubernetes, there's something called kubectl. It has a command line as well. On the web console, you can just click that question mark, and there's a command line tools button here. You can click that and it gives you instruction how to install and use that tooling. And then you're set. Okay, so let's go and build a little demo. And as I said, I like camels, and in particular this camel because it's a Lego camel, and I'm from Denmark, and the company Lego is also from Denmark. So it's like our version of IKEA, if you're from Sweden. So let's build a little camel demo. And the source code for that demonstration and the slides for this talk is on GitHub on my account there, Claus. You can find it there on Minishift Hello. So what we're going to do is build a little hello service. So we have a hello service, and we have a client that want to call this service. So with 2 microservices, you can say if you want to stretch that a bit far and get that running in the cluster. So we want the client to call the server, the hello service, and get a response back. And in that response, we want sort of the host name where the service is running, so we can see that in the cluster it's dynamic. So when we scale up and scale down, we can see the different response and so on. So we're going to implement that using 2 popular Java technologies. One is Spring Boot, and another one is Wildfire Swarm, and we're going to use HTTP as the transport. Very good beginner example. I like Camel, so I put Camel inside these 2 implementations. And in Camel, it's fairly easy to implement such a solution. On the client side, we don't want to click something ourselves and so on, so we actually use something called a timer in Camel, so it actually triggers automatic. Then we're going to call the endpoint, the service using HTTP, and then we're going to log the response. And on the server side, we just have a HTTP endpoint using Undertow as the HTTP server, and then we do a message transformation where we give that response back. And that's it. So when you start developing using Wildfire or even so on Spring Boot, it's become popular to go to these websites they're calling Spring Boot Start and Wildfire Generator. You can choose your dependencies and sort of create a little skeleton product and then click a button to download your product, and you can go from there. So that's what I did. So I'm on the Wildfire Swarm side where we have the hello service. I implemented 2 Java classes. One is called a hello route. This is from Camel, where you can define routes. Then I have injected an endpoint for the Undertow, and then I injected the bean, which is where we're going to build that response message. And then down in the bottom, that's the Camel route. Just say it's from Undertow, and then call a bean that's called hello. And that's it. The source code for the bean is very simple. It's a single class with a single method called say hello. And as you can see on the response, we say swarm says hello from, and then we use a little code to get the local host name, and that's it. Then the Spring Boot application is also created similar like Wildfire Swarm. We go to the Start Spring IO website. We choose our dependencies, the web dependencies, the Apache Camel, and then something called Actuator. So Actuator is something that becomes important to use when you build an application for the cloud where you need to have some sort of highly available, resilient application. And Actuator sort of allows that with Spring Boot, where it allows us to use something called health checks in the cluster. So just pay attention that you remember to choose that one. On the Spring Boot client, there's also a Camel route there. It's just called my route. It has a single configure method. So it's from a timer, call the HTTP endpoint, and log the message. And that's it. And how many people here are using IntelliJ? Oh, that's maybe in the room 20%. That's good. So there's room for improvement. But what we have in for IntelliJ is a nice little Camel plugin that sort of gives you some Camel power. Let's try to see that one just a little bit in action. So the Eclipse guys can start to download and install that one instead. So here is the client side with the Spring Boot. It's a lot of source code, but so here I have, for example, have the timer endpoint and say foo and parrot. So in Camel, the idea is that you can configure endpoints using a string. So if you want to configure the timer endpoint with other options, normally before this plugin, you might have to go to the website, find the documentation, figure out which options there are, and type them. But here I can just press Control Space, and it shows up a pop-up with the possible options you can configure on the timer endpoint, which you have not yet used. So, for example, I can use a delay. What the hell is delay? I can, pop up a documentation on the side here that shows me what delay is. And if I scroll up and down, the documentation updates over there. So I can just look at that. So, for example, if I want to say exchange pattern is equals something, and then it needs a value, Control Space. Now it knows it's an enum, so then it shows you which possible options you have here to choose among. And also, if you want to go to the documentation for that, there's a shortcut for that, Shift F1. So if I press that one, it opens up the web browser with the documentation for that endpoint. You can see this is the timer one, and you can see the documentation in Camel, blah, blah, blah. The tooling has more powers in other areas. The tooling has more powers in other areas. Down here, there's something called a simple expression. If I type a mistake, it gets this red underline. So if I make a mistake there, it can tell you something about that as well. Okay, just a little teaser there. So now we build, I built the client side with the Spring Boot and the server side with the Wi-Fi Swarm, and if we're not running in a cloud, I can actually run them locally here. So I can use the Maven plugin for Spring Boot run, and Wi-Fi side run, and they can communicate with each other using HTTP on localhost 8080. But we want to run it in a cluster. So that's the next step. So how do we take our Java application and run in a cluster? And for that, we need to build what is called a Docker image or container image. And how do we do that today? So we have some source code in the Maven project, and then how do we go from there? Well, then you can use some Maven plugin for that. Roland Hus was giving a talk previously. He's one of the main author of this plugin. So what this plugin can do is to take your Maven project and build it as a Docker image for you. There's a build goal for that. Okay, so how do you get this plugin then? Well, you just add it to your POM file. Fabricate Maven plugin and the version number. So that's one way of doing it. But you may not know, but in Maven, you can execute any Maven plugin and any version and any goal if you type in the long name of it, which I've done up here, with the group ID, artifact ID, and the version. So the Fabricate Maven plugin has a goal called setup, so it can install itself to your POM project. So you just type that one, and it adds itself to the POM file. When you do that, it adds these lines of code here to your POM file. So besides adding itself, it also attaches itself to some of the Maven life cycles. So when you build your product, it can automatically start to build your Docker image and so on. So when you build Docker image, there's a difference between doing that, whether you run it on Kubernetes or OpenShift. So OpenShift has something they call it source to image that allows OpenShift to build the Docker image for you. So you don't build it locally on your host operating system. So that means you don't have to install Docker locally to build a Docker image. You can let OpenShift do that for you. But if you don't use OpenShift and you're using Kubernetes, for example, then Kubernetes doesn't offer that. So then you need to install Docker locally. Then it can build a Docker image for you. When you're building your Docker image, for example, using OpenShift or OpenShift source to image, it will also log the output of the build process on your console here. You can see what it's doing. And you can go to the web console and also see the build process there and so on. We're going to do that in a moment, so just going to skip some slides. So when you run the local cluster, it's all underneath still Docker. So you can actually use the Docker command line if you have that installed and type Docker image and Docker PS and something like that. And for example, here I Docker image. It lists me the local Docker image I have on this computer. So what we done now is to have the Docker Fabricate Maven plugin build these two Docker images, and now we want to run them in the cluster. Are we ready to do that? Not entirely, because when you run your application in a cluster, it's a dynamic platform, which means essentially your Java application or your application per se can run anywhere in the cluster. It's much more dynamic. So suddenly your Wi-Fi Swarm application is running here and your client is here, but how does the client know where the Wi-Fi Swarm application is running? Because it can run anywhere. It's not able to call that service over here using localhost anymore. So we need something else when we communicate with our application in the cluster. And for that, we can use Kubernetes service. So what we need to do on the Wi-Fi Swarms side of things is to define this as a Kubernetes service. Then the client is able to call it. Okay, so what is the reason and how does this Kubernetes service works? Slide. Good timing. So the reason for the Kubernetes service is, as said before, it's very dynamic. Your application can run anywhere. So in the cluster, when you run application, it runs inside something called a pod. A Kubernetes pod is the minimum deployment unit where applications run. So the cluster can actually scale up and run multiple instances of your application in multiple pods. So now there's two pods with the Hello service, and there's one pod with the client. So the client want to call this service, but now there's two. Which one should I choose, and how do I figure out this? Again, this is where the Kubernetes service come in. It sort of sits in between and does all that communication in between for you. So you don't really need to think about that. So the Kubernetes service is static. That's very important to know. And in fact, the Kubernetes service is just a network address. It's an IP and a port number. That's it. It's a static IP and port number. So when that service is created, the Kubernetes platform assigns an IP and a port number for it, and that stays the same for the entire lifecycle of that service, which means the client that want to use or call that service just needs to get an IP and port number one time and can use it forever, regardless where the pods are running. So all these pods are dynamic, even the client. So for example, if you have a data center with a rack, a node that runs all these pods, and that rack crashes, then the Kubernetes cluster will detect that, and then it will reschedule these pods to run somewhere else. Now they are designed and running somewhere else, a different node and different IP and port number and all that kind of thing. But the service is still static. That never changes. Also, because the service is just a virtual IP address in the cluster, that means as a Java developer, you do not need to have any Kubernetes Java library whatsoever in your project. You don't need to download some Kubernetes Java, use some special Java API from this library to discover and call service for it. No. It's just standard networking, call it IP port and port number, that's it. That's really awesome. That means it's not only Java code, it also works for .NET and JavaScript, whatever it is. It's standard IP and port number, that's it. That's freaking awesome. So here's some more detail what's going on. So when we have an application where we host a service like the Hello service over here on the Wi-Fi Swarm side of things, when that is deployed inside the cluster, it registers itself in something called a Kubernetes master. Then the Kubernetes master is propagating all these service changes to all the running nodes, and on each of these running nodes, there's sort of like a little daemon running. It's called a kube proxy. This kube proxy listens to all these service changes. So the kube proxy on all the nodes know at all time where all the services that exist in the cluster and where they currently are. So what happens when the client want to call the service? It gets this IP, it has this IP and port number, and the client thinks that I'm calling some remote node somewhere But it's not. Actually, because of some sort of IP address magic, whatever they're done, it actually ends up calling the local kube proxy. And then the kube proxy say, thank you, okay, you want to call this service. I know where it is. Just relax. Let me do all the work for you. And it calls the service, get the response, and give it back to the client. And because the kube proxy sits in between, it knows where all the existing running nodes are, the pods are, then it is able to also load balance between them if you have multiple pods running concurrently. So, and you have different algorithms to choose among. And you may think that it's using round robins, and then go back. No, by default it's random. So, and I guess it used to be round robin, but you know they actually did some analysis and find out that it's actually better just to do random. But again, this was high level. You don't need to care about that so much as a developer. You just need to know, I want to call a service. It's an IP and a port number. That's it. So how does we make that client call this service? So the initial support for service discovery in Kubernetes was based on environmental variables. So what happens is that when a pod starts up, Kubernetes will inject all the service as the environmental variables using this convention with the service host, service port. That means it was very easy for any programming language whatsoever just to look up environmental variables to get the IP and the port number. Again, there's no client library whatsoever. It's all on your local pod running there. But since Kubernetes comes with a little DNS cluster out of the box, so that is probably what people are preferred to use now instead of the environmental variables. But you have these two choices. In Camel, we made it easy to call a service where you use this double squirrely, service, colon, and then the name of the service. That's it. But you can also use DNS, and by DNS, it's actually going a bit back again because now you can actually hard code the name of the service. That's the host name. And then Kubernetes also allows you to just freely choose the IP, the port number of that service. So here I've chosen 8080. So when I create a service, I can tell you, okay, I have a service over here. It's called Hello Swarm, and it's 8080. You can say, okay, you can hard code that in your application. That's it. It never changes. That's kind of scary because you think everything is dynamic, and we have to have external configuration files and so on and so on. Now we actually go a bit back again, and we can actually hard code that. Still, it's a bit scary. And sometimes, if you want to make it even easier using SLP, you can just use port 80 by default. Then it's just Hello Swarm. Okay, so if we make these code changes, now we can actually run in a dynamic platform. The client can call the service now. Okay, but how do we take our Docker image or our Java project and run in that OpenShift or Kubernetes cluster? Again, with the help of a Maven plugin. So the Fabricate Maven plugin has a deploy goal. So it can actually deploy your application in the cluster for you. So what I've done is already pre-deployed the Hello Swarm application. That was this one, blue circle with one. And now we want to deploy the client. Before I do that, there's one thing I want to mention also. You can also use the run goal. So what it does, the run goal is doing the deployment in the foreground. So it actually logs on your Maven output, and when you press Control-C, it undeploys it automatically. And then it's sort of like if it runs on your computer in your host operating system. But it actually deploys in the cluster, and it runs it there until you press Control-C, and then it undeploys it. That's also a good way to develop and try something. But okay, let's go and deploy our, there's a new version. Let's install that one. No. So here I have the client. I just type Maven fabricate :deploy, and it starts the deployment procedure. What I want to do now is to switch to the web console, if I can be fairly quick over here. It's developer. It logs me out, of course. The default login is developer. Thank you. You can see I also need to log in on the client side. So that's one thing, is OpenShift is a bit more restricted there with the logins and so on. Kubernetes not. So apparently I logged in yesterday, and the token is sort of expires after maybe 24 hours or so, and then of course during a demo, right? You know, an hour ago it worked fine. So here the swarm is running. Now let's see, the client did not deploy because it failed, right? I couldn't deploy it. So let's try again. Maven fabricate deploy, and hopefully it starts deploying. And up here, if we're really fast, probably too slow, but here's something running. There's a build running here, so it's actually building that on OpenShift, but it's fairly fast. And the reason is I got a new laptop. So this new laptop is actually much faster than the old one I had. The old one was a MacBook Air with 8 gig of memory and 2-core CPU. Now this is a 16 gig and the latest Mac. And now it's running. So the client is running up there. And we can go and look at the pod. And we can see the logs from it. From here, for example, you can see Swarm says hello from, and then we get the host name from that. Oh, this is really dark. So, but I'll just show you, you can also do the same from the command line. So there's one called OC get pods. The command line has a lot of get pods, get service, get namespaces, get nodes, get whatever. So there's a lot of things you can do with get. So up here, the client is running. So I can type OC logs and follow, and the client name, and you can see it running down here. And you should see it's calling a pod. Now, let's try to scale up the pod a bit. So I'll go up here and try to scale it to 2. And it's scaling up. And let's see if something happens here. Oh, fuck. Something is happening. So maybe I need to, give more beers for the demo gods. I shouldn't drink all the beers myself. I should give one for the demo god and one for me. Okay, so what's happening now? You can maybe see that it starts actually to load balance between the 2 pods running now. If you see over there to the left side, the host name are a little bit different, and it's by random. One is 92, the other one is Q something 68. Okay, but why was there this exception? So this is actually a bit on purpose, but I want to tell you, when you build application for the cloud in a cluster world, failures can happen. So it can actually, inside the cluster itself, failures can happen. But why did Kubernetes not scale up that pod in a resilient way? It can do that, but as a Java developer, you need to prepare for that. There are 2 sides. There's the client side, and there's also the server side. So the client attempts to call a service, and that failed. So you get a section in the head. Maybe you want to retry that or do something about that failure. So let's take a look at what option you can do there. So over here, you might have seen I have prepared some code in the top. So Camel allows you to handle exceptions using different ways. One of them is the error handler in Camel, where you can say, okay, if there was an exception, I want to try this up to 10 times and with 1 second apart, and try to see if you can fix that one. So I can just try to do that. Maven fabricate deploy, and it will redeploy that application. And at the same time it's deploying, let's scale this down to 1. So we go back as before, and then we will see what happened next time. Up here you can see the transition from the client is actually deploying now. Now there's a new one starting up. The old one is actually still running because the cluster will only switch over to the new running part when it's fully up and running. Now it's light blue, that means it's booting up. It's not fully ready yet, but at the end, when it becomes ready, that one will get all the traffic, and the old one will be shutting down. Now it's the new one running. And if you go here, we can see you have to tail the logs again. Just we'll see logs follow. So now it runs down there, 92, and we try to scale it up again. Scaling up to 2. Let's see what happens over here, if any exceptions or not. It's still 92. Yeah, still 92. There's so far no exception. Down there's a new one, K6. So that was one way of sort of building or considering errors from the client side of things. But there's another way. But before we talk about that, let's just go to some slides, and I can prepare you guys for that. Scaling, we've done that. So this is what happened with how we solved this. So we had this error handling with the client. The client was trying to call a service. The service failed somehow, and then we can just retry it. And then suddenly it works. But this is not always the best solution for you, because when you do this, then you actually prolong the service call, because maybe there's a downstream upstream service that calls you. Then it has to wait, for every redelivery. Maybe it takes 8 seconds. Sometimes you don't want to do that. Maybe you want to fail fast or not. And for that, there is, and just imagine that if you have a lot of clients doing that, and this downstream service here is really under stress. It can't handle all this traffic. Too many people are calling me. And if every time I fail, it doesn't really help that you just try to retry calling me, because I still fail. And just imagine more and more do that, and I get more and more stressed. So that's the problem. It's called the thundering herd problem. Big thunder, just keep calling. No, I cannot do that. So there's another pattern for that error handling pattern called circuit breaker. And in the open source world, there's a popular framework called Hystrix, Netflix Hystrix you can use. So the idea with the circuit breaker is that if the service starts to fail, then it's sort of like a light switch. You flip over, and then it just stops calling the service, and maybe you have a fallback scenario. Instead of really calling the service, you can maybe do something else. If not, you can still fail or whatnot. And then, while the service is failed, it can go to this once in a while. It can try to call the real service again. Maybe the service is up and running again. Then it can come into this half open state, and after a while, okay, everything is fine. Then it becomes ready again, and it's green. So let's try to see that in a moment. So I will just go and shut down the client here, and then I will call one of those, so we only have one service here. And up here, I have prepared a client example using Hystrix. So let's just try that in a moment. No, sorry. It's here, and just boot it up. And we have this one. So I'll go here, OC, get pods. Let's just look at the pods and client history up here. I'll just log it again with the follow. So now it's calling that guy again. You can see over here, hello swarm 92 something. Now it's using Hystrix instead of Camel's error handler. And we can do the same thing. We can, scale up and scale down and kill the pod and whatnot. But let's see if we can get Hystrix monitoring working as well. Let's just refresh this one. I was trying to make it over here so we can see it immediately. So what I have here is the Hystrix Dashboard, which I've installed in the cluster. Now, in the README file of this source code, you can find how to do that. There's a few steps you have to do, but you can actually do that. So this is running in the cluster. It detected that this part with the client now has Hystrix enabled, and it exposes all the Hystrix statistics that Hystrix Dashboard is able to capture. So you can get like this aggregate view of all your pods with Hystrix. So there's one called CDR, now called Hello Swarm. This is the Camel client. And it's actually just running fine. It's green, that's fine. There's nothing wrong with the service. So we can do a bit of things again. So just to be really evil, I'm going to show you that it's still Docker. Oh, eval. So I'm running this command. Now I can actually use Docker. Docker PS. I can see all the processes, Docker processes running in the cluster. And I'm trying to find the Hello Swarm. It's a bit wrapped the text here, but let me see client, Hello Swarm. This is the guy. So here it is, this one. This is the Docker process ID. So now I'm going to say Docker kill the process, and switch over here to the dashboard. Let's see if something goes wrong. Now you can see S20, 40 something error now start to fail. Oh no, no, no. And you can see the circuit is open. Oh, now it's closed again. Now it's green. It goes very fast. So we killed the Wi-Fi Swarm application. We started to see failure. The Hystrix detected that and it opened the circuit breaker. Then it started actually realizing, okay, now it's running again, and then it closes it again. And that's the one thing to have to about Hystrix is that closed is good and open is bad. That's like the reverse in your mind. But if you look up there, it's green. So we love green, right? If you're colorblind, then you might have a problem, but it takes a little while to figure out. So it's able to recover from that. Okay, so let's go back to the slides. And how do you implement this in Camel using the Hystrix circuit breaker? It's not too, it's fairly easy. Just say Hystrix, and then whatever you put inside that block is protected by the Hystrix command. And then you can choose to have a fallback. And I just said, okay, if you can't call the service, I just do a constant message saying nobody wants to talk to me. You know, that's it. And we saw the dashboard. One thing is also very nice is, as a Java developer, is being able to debug. But how do you debug in a cluster when it's not really running on your local computer? It's running inside that cluster that's also running on your local computer, but they are not. No. So how do you do that? It's actually not as easy. But again, the Fabricate Maven plugin has a debug goal that makes it much easier. So let's try that. So over here, I'm actually just from the website calling that service. Now I want to debug that. So something is wrong. So let's do that. But before that, I just want to shut down the Hystrix so it's not keep calling us. So scroll it down to 0. And here, this is the error when we killed it with the Docker PS. Now it's running. We only have one. So we want to debug that one. So for that, we need to go into the product where it lives. It lives here, and I just type Maven fabricate :debug. Now, what that does is actually starting. It's that pod that runs your application. It enables Java debugging, Java remote debugging. Now it has done that. I can go to my Java editor and go to that product with the Hello Swarm. Up there is the source code for that. And I set a breakpoint here. This is the one I want to debug. So I can go up here, run, debug, and I can set up a remote debugging. This is standard remote debugging in Java on port 5005, and I can click debug. And now it hopefully has that breakpoint enabled. So if we're a bit quick, I can go here and click refresh here. And it stops the breakpoint here. Here I can see it, and I can say type something else. If I'm really quick, oh no. And then resume. And let's see. Hey, Barca rules. So and if I call it again, the breakpoint is hit, and I can just resume, and it goes back to the other one. So that's fairly easy to have in debug facilities as a Java developer. Okay. Type of that. Remote debugging. So when you use the work with the local cluster, as that there's this local command line tool called OpenShift OC, and Kubernetes has kubectl. They can do more or less the same. Here's just some slide with some of the good commands you can use. Get pods, you've seen me do that fairly. There's also this OC logs, which I did to follow logs from the running pods. You can get the service, you can get something called the routes. It's a HTTP route to the service, so you can call them externally. And if you want to call a service and from your web browser, then there's this long command you can type. Minishift, OpenShift, service, the name of the service, and the -n and the product name. And it will give you that URL, and you open it in the web browser. Okay, so what was the goal of this talk? So as a developer, as a Java developer, the goal was to show you how you can get started developing cloud applications locally on your computer. So how you can build your Java applications as Docker image or Linux containers, and then take these containers and run on OpenShift or Kubernetes. And I've shown you how you can use the Fabricate Maven plugin to do that. So that is actually a similar developer experience that you guys are probably already doing today. Just develop your Java code, use Maven tooling, and have a local cluster running. And you don't. And later on, if you can have a real cluster running, and all you're doing here works similar on the real cluster, because all you have to do is just point to which cluster to use using a URL in the tool, and all the Maven plugins and so on, the remote debugging and whatever I did, it can actually run on a real cluster as well. Okay, so when you start developing for the cloud, there's a lot of concepts to learn. So this is sort of like this iceberg just flipped over. So this is from Bilgin. He posted a great blog post about how the things as a Java developer you have to consider when you go to the cloud. So something like self-healing, you have to how to build resilient and fault tolerance applications. I've shown you a bit about how the error handling and the circuit breakers. There's also something about centralized logging. How do you do that, and how do you trace your business application, the message going on? How about configuration management? I mentioned a bit about health checks and so on. So there's a lot of concepts to master and learn, and this sort of pyramid has a good inspiration for what to look into. And of course, there's also good books about how to get started developing. Here are two good books that are for beginners. One is by Christian Poster, called Microservices for Java Development. It's freely available on this website, but I think Red Hat, we offer this book as well on, if you go to the booth. I heard we had 250 copies or so of this book. There's another book called OpenShift for Developers, which is also great, by Grant and Graham. And of course, there's also This Is the Best book. It's not yet finished, but will be. You don't get rich for writing books, so I still have to work, unfortunately. There's a little discount code called Camel 39. It gives you 39%. I wish there were one called Camel 99. But maybe you can try going down 98, 98, 97, until maybe there was a higher one that works. Or maybe try Camel 200 and get a free book. Okay, the links, 2 minutes left. So you can find the slides and the source code on my website. I will also post a tweet and whatnot. So questions? I guess we are hungry, right? You want to be first in line for the queue for the food? Okay, thank you, and remember to give the votes, otherwise I don't know if this talk was crap or just a little good. Okay.